Hi, in this video, I will show you how to send container logs from AWS EKS cluster to AWS CloudWatch log groups using Fluentd. As you see in this picture, this is just a pictorial overview of my demo. Here, I will be leveraging AWS EKS cluster, which is a managed cluster. So on top of this cluster, I will show you how we can pass the, container logs into a CloudWatch log group. So the CloudWatch log groups is a native service from AWS, which will help us to gather all the required logs, and through that service we can do analytics, alerting and responding task can be done from the this kind of service. Yeah. All right. So since the Amazon EKS and CloudWatch logs are native services, this solution, this observability solution at AWS EKS becomes a very feasible and very handy, I can say. Yeah. All right. So basically, so what I show in this demo is I will give you a pictorial overview. I will give you an architectural configuration overview, and finally I will walk you through the step by step task that you need to perform to establish these connections, and also I will show you the how does the log looks when the logs comes to AWS log log AWS CloudWatch log groups. Yeah. All right. So as you see in this picture, so this is just a pictorial overview. Where let's say I have an AWS EKS cluster. This is my AWS account. So here I will be I have already created a EKS cluster. So on top of this one EKS cluster, I will show you how did I configure Fluentd, which can extract the logs from the AWS EKS cluster and push us into the CloudWatch log groups. Yeah. And from there, how we can weave the logs. Yeah. So that is what the main aim of this demo. So once the EKS cluster is created, so I will show you, like, how do you need to do the rest configuration, the required configurations, and also map the logs being extracted from the Fluentd to the CloudWatch log groups. Yeah. And finally, I will also show you a view in the CloudWatch log groups, like how does the logs looks. Yeah. All right. So that's all. So for now, and finally, if before I start the real time demos or real time walk of this demo, a kind request, please just subscribe my channel. That would really encourage me a lot. Yeah. So with that note, let's directly walk you through the steps I need to perform in to establish this this demo. Yeah. All right. So for this case, as usual, what I did is I have already articulated the all the steps that you need to perform to achieve this to achieve this this setup in general. Yeah. So here to set up my EKS cluster, right? So as you know that EKS cluster setup needs almost like 15 to 20 minutes. Okay. So for that case, what I did is I already pre-created a EKS cluster, and then I ran all these steps one after the other. I have already ran those steps in my PowerShell window. So all these commands I'm you leveraging Windows PowerShell to run these commands. Yeah. All right. So here the prerequisite is you should have your system installed with the ekctl utility, which is with the latest latest version of ekctl utility. Then you can leverage this command called ekctl create cluster, and name of your cluster, then the node type, then the minimum and maximum node counts, the region and the zones. Yeah. So if you give this data and run it, yes, you will have your EKS cluster gets up and running fine. All right. So this is the first part. Okay. The first part you see is all about handling EKS cluster with using ekctl utility. Whereas the down the line you have the 7 step. Okay. So you see 1 2 3 4 5 6 7. So all these steps are dedicatedly meant for configuring the this observability solution at AWS EKS cluster. Okay. Here I also use multiple YAML file, nothing but AWS EKS configuration specification files. Yeah. Especially since I'm configuring the Fluentd as a a service which extracts the logs. So we need to configure the Kubernetes config has to be done for that service, because the Fluentd service is acting as a daemon set in the EKS cluster. Yeah. And also the required role binding is has to be there. Then we have to do a daemon set configuration for Fluentd, and a sample app which triggers the logs to be extracted from the Fluentd and push it into our CloudWatch log groups. Okay, these are the required files. Anyways, these files will be showed in the my GitHub repo, and the GitHub repo link will be shared in this video's description. Please find this file from there and try to do the same steps I will be I will be dictating here. Yeah. All right. So now let's go to this PowerShell window, and I will walk you through the step by step. I will give the brief about like what did I do to perform these steps as expected way. So here my major goal. Okay, so my major goal here is just to use a command line tool and establish a connection. Okay, because anyways the configuration setup is done only one time when you have a one cluster. Yeah. For example, if you are managing observability as an infrastructure as a code, then probably you need to go for the infrastructure as a code technology like Terraform, CloudFormation template, or any other code way. Yeah. All right. So first one, what I'm doing is I'm setting my AWS EKS AWS account context with using AWS CLI command. Yeah. So here again, you need to have your system installed with the AWS CLI. If not, please do watch my previous videos where I have explained around like how do you can configure AWS CLI in your system. Yeah. All right. So once you type this AWS configure, you have to provide AWS access key ID and the secret access key and the reason where you want to set the context of the AWS account. So that is the reason, and the default output format, that is a generally JSON is expected. Yeah. All right. Then finally, once I'm set with the context, I'm just directly jumping and running this command. Right. You see here I'm running this command. So what I did is I copy pasted from this file. Right. I copied this line from this file and I put it here. That is EKCTL create cluster. This is my cluster and that is my EKS cluster. Then the node type is, this is my node type. I'm using t2.large and I'm keeping my nodes only one, to save the cost. Yeah. And the reason is US East 1. You see the reason here, you see the whatever reason you are setting here has to be mapped here. Okay. Or else you might get the errors. Then I'm mapping the zones. Okay. So zones is nothing but allowability zones. So these are the allowability zones belongs to that US East region. All right. So once you hit this command, so it will take nearby 15 to 20 minutes to spin up a EKS cluster. Okay. So for your information, since I'm using the latest EKCTL utility, it maps the default EKS cluster creation to version 1.2.1. Yeah, that's the reason my EKS cluster version is 1.2.1. All right. So if I show you the time here and let me go above, so you see it has started at 11:40, and if I can scroll down, and it has taken almost like it has taken almost like 17 minutes. Yeah. So it has taken nearby 17 minutes to spin up a EKS cluster, which is a lengthy time. Yeah. And that's the reason I have kept it out of the demo. So once I hit this command, you see my EKS cluster is up and running fine. Yeah. And so how do you say that your EKS cluster is up and running fine? Because by seeing the status called active. Yeah. That indicates that your EKS cluster is fine. It is working fine. Yeah. All right. So now we have set our basement called EKS cluster. Right. Now let's go to the real time real time commandlet run, so that how we can establish you know this setup and have a observability solution configured on your EKS cluster with using native services. Yeah. Anyways, Fluentd is open sourced and the CloudWatch is a native service. Yeah. All right. So your observability solution is ready made. Yeah. So I recommend this easy way of handling the observability at Kubernetes world. Yeah. Okay, so let's go to the next command. So next one, once a EKS cluster is created, I'm just checking if the kubectl commands are working fine. So in that case, what I did is I just ran a random command called kubectl get nodes. Yeah. So kubectl get nodes is nothing but it is just a EKS cluster command which will which will help you to get the number of nodes running currently on your EKS cluster. Right, that is what I'm getting here. Right, since I mentioned about that I have configured, I'm setting only one node. Right, so in this case, that's the reason my EKS cluster node is 1. Okay, now let's go to the next command. So you see I am following the next commands. You see this is the hardcore configuration steps. Okay, you have to follow these steps to achieve the required setups. All right, the first one is as usual, we have to create a IAM IODC identity provider on your EKS cluster, so that that identity provider can be used by your EKS cluster to establish connection back to the IAM, that is AWS IAM. Yeah. How it is different? Okay, you might be having the question, well, how it is different? It is different because the IAM is sitting in the context of when I say IAM is it is a native service within the AWS account, but your EKS cluster, right, which is a IaaS service, that is infrastructure as a service in general. That is a combination of PaaS and IaaS, I can say. But yes, the services will be running in a real time virtual machines. Okay, that is nodes. Inside the nodes we have the containers, pods are been running. All right. So since the EKS cluster is a is a node based service, right? And you need to have the IAM capability to be communicated on the IAM services, which is in the AWS account. So in such cases, this is the connector, I can say. Yeah, this is the connector. IAM IODC identity provider is like a connector which helps the EKS cluster to leverage this the service capability provided by the IAM service. Yeah, that is I'm just explaining you in a layman term. Okay. If you don't do this, probably the IAM roles and the IAM service, IAM policies that you are attaching to the service account may not be working, right? And this is the connectivity. This is a kind of a plug. This is a kind of a plug which will plug between IAM and the EKS cluster. Henceforth, the IAM roles and policies starts working. Yeah. All right. So once you do it, right? Once you do it, so this is how it looks. Once you run this command, right? It takes nearby, just a second. So a few seconds, and it creates, okay, created IAM open ID connect provider for EKS cluster. This one, yeah. All right. So that is a one step, and then the next one is, let's go to the next command. So next command is create a service account. So why do we need a service account? So as I said, the service accounts will help you, to communicate from the IAM, from IAM service to AWS EKS service. Okay, so that helps you to, that will help us to provide a required permissions from the IAM, which is a native service from AWS. Okay. All right, so henceforth we create a IAM service account, that is a service account within the EKS cluster, right? And this is the big command that we need to follow. And also here we are attaching a native policies of IAM service. Yeah. So let me walk you through the next command. So next command is I'm creating a service account. So for that case, what I'm doing is I'm using the command again, ekctl create IAM service account. So this is a command, okay? This is a ekctl command that you need to run. And you are giving the name of the service account as a Fluentd, okay? And the namespaces we are keeping it to a system namespace, that is a kube system, and this is the cluster name, and we are attaching a, that's what I was telling, right? So this is the IAM policy, we are attaching it, okay? And this is a service account local to the Kubernetes nodes, and it is referring the policy sitting in the IAM service. How it is working? Because we have identified, we have associated a IAM OADC providers, okay? That is a service which brings a bridge between these. All right. Next one, approve, right? We are making the approve in the sense we are just taking that, and if some existing IAM service account are existed in this cluster, just to do a overwrite. All right. So once you run this command, it will take certain time, right? It takes this much time, and finally you should see created a service account, kube system for Fluentd. Nothing but it is sitting under the kube system namespace, and the name of my service account is Fluentd. That is what it tells. Huh? Right. Okay, so after this command, so we have to go to the next command. So let's see what is the next configuration that you need to do for this demo. The next one is we have to do a cluster role and cluster role binding. So for this case, I have created a cluster role and cluster role binding YAML file, that is a Kubernetes specification file. Yeah. So if I go to this file, I will just walk you through this one. It is a 24-line file. So here, what we are doing is we are just declaring this is a Kubernetes specification file. So here API version belongs to this RBAC authorization kubernetes.io /version 1, and the kind is Kubernetes cluster role, and metadata is it contains a name equal to Fluentd. And inside this the rules, we are defining the rules like API groups, resources, then the verbs. Okay, so nothing but we are providing the required permissions to the namespace and the parts. Yeah. And finally, API versions, you see that we are doing a cluster role binding. Okay, so here we created a cluster role, then we are binding the cluster role with the service account, right? And this is the steps which does that. Okay, so if I can expand this, right? You see the cluster, it's a kind is cluster role binding, and the name is Fluentd, and the API group is this one, right? And the kind is cluster role, yeah. And the subject is nothing but service account, which is the service account Fluentd, which we created in the namespace. Okay. So this is like it will create a cluster role, and it will do that role binding with the service account. Okay, and henceforth this has been defined in a specification file. And how do we run it? To run this one, we have to do some exercise. Okay, for example, what I did is to establish that to run that command, what I did is I just ran blindly kubectl apply -f, and I gave the path of I gave the name of the file, but I did you see I basically I didn't do cd to this path, but I didn't change the directory of that file, but I directly run it. It eventually failed, right? This is the kind of a learning for you, because to do that, you need to switch the directory to the folder where this file is sitting, right? So the folder where it is sitting is this folder, right? And when I did a cd, it changed the path to that. Yeah, you see the path is being changed now here. And then I did kubectl apply, right? That is, but I applied cluster role and role binding YAML file. And finally, it created two things for us. One is, it created a cluster role, and it did a binding. To which binding? It did a service account role binding. It has done. Yeah. All right. So that is the next steps that we did. Okay. So let me go to the next one. So next one is create Kubernetes config map object for the Fluentd configurations. Okay, so we have to do a config maps. Okay, the config map, as you know that in AWS world, it is just a kind of you are creating a kind of hash table within the Kubernetes, yeah, which will be leveraged by the services, or which will be leveraged by any kind of pods or daemon sets running on this EKS cluster. Okay, that is what the Kubernetes config map object does. Okay, so for this case, in simple term, we just need to run this command to configure the Kubernetes config map, which will be used by the Fluentd down the steps. Now again, this config map configuration is been done with using again YAML specification file, which is a very big file. Maybe it will take some time, but I will just quickly walk you through this one. Yeah. So as I said, this is the API version 1, and we are doing container config. Yeah. So these are the container config. Then we are doing the Fluentd configurations. Okay. Then we have the system configurations. Yeah. Anyways, this is a very lengthy file. It contains. Okay. This is the file where we contain. We have given multiple data. For example, if I show you. Right, so this is the file we are telling, we are telling we are telling the Fluentd to do what kind of job, yeah, in the sense, what are the, the metrics, what are the logs that it has to extract from the Kubernetes cluster and put it under the CloudWatch Logs groups. Okay, that is the all config maps are being done here. Right, so you see there are one sources have been configured, and if I can scroll down, right, and here you go. This is the CloudWatch Logs. So at the CloudWatch Logs groups, it has to create a log group name with this name, yeah, which contains a cube hyphen nest. This is the and it is fetching the environmental name called cluster name, that is my cluster, yeah, my EKS, and this is the container. So this is the log group name will be framed under your CloudWatch log, and the logs will be streamed under that groups, yeah. All right, so this is how log groups will be created. Log groups will be created to push the logs. Okay, and this will be done by the Fluentd. And after that, we are doing the fluent dot configuration, nothing but it will configure the Fluentds. Okay. All right. So next one. So this is the system md.config system md.config. Okay. So this is what we are doing. All right. Anyways, this is a big file. Maybe this is a standard file. Okay. This is a standard kube config file which is needed to extract the logs from the EKS cluster and put it under CloudWatch. All right. Okay. So to run this configurations, what I did is I have to run the same command called kubectl apply -f, nothing but file path, and path is nothing but current directory, yeah, with dot operation is nothing but current directory. And what is the file name? So this is the file name I need to run, and that is what I did here. Yeah, so if I go down, right, so kubectl apply I did, but there was an error. Okay, so there was some error there was syntactical error, right, which I fixed later. Then I run the command called kubectl apply hyphen f, and this is the config map file I gave, and finally it created a Fluentd config map purpose. All right, and that is what that is how the config map configuration is done from my side. And after that I will go to the next step, that is next step is we have to configure the Fluentd as a daemon set. Yeah, you see the script to run the Fluentd container as a daemon set object. So this is the specification file where I have explained everything here. Yeah. All right, so next one, let me go to the daemon set configurations and I will explain, okay, what I'm doing here. Yeah. All right, so this is the bit very important file. This is the file where your Fluentd object, Fluentd pod gets created. Yeah, and you are also telling that part to do what kind of job. Yeah, okay? It has to extract those logs and put it under CloudWatch log groups. Yeah, and this is the file does that. As you know, the daemon set is nothing but a kind of a feature from the AWS EKS or from the Kubernetes world. This when you say type kind equal to daemon set, nothing but when you deploy these daemon sets, it will make sure that a single pod, at least one pod, is sitting across the nodes of your Kubernetes cluster. Okay, that is the specialty of daemon set. Okay, if you directly put a Kubernetes pods, if you directly creating a Kubernetes pod without a daemon set type, probably the pod might be running in one node or another node. It might be running anywhere else. Yeah, but when you specify that it's a daemon set, nothing but you are telling I need at least one pod on all the cluster nodes present in the Kubernetes cluster. So here let me walk you through this file. So here the kind is daemon set metadata. Then this is the this is the labels. Okay, in the metadata we are using the labels for Kubernetes app called Fluentd-CloudWatch. Okay, and the name is this is the Fluentd-CloudWatch again, and the namespace here is nothing but I'm putting under kube system only. Yeah, In the specification, we have the selectors. Okay, selectors is the place where you will be image will be selected. Okay, so every part's been created with using a Docker images or any other images. Okay, generate Docker images. Okay, so here you see the match label is nothing but Kubernetes app belongs to this image called Fluentd-CloudWatch. Okay, this is the publicly available image which will be consumed when you run this command, and the pod will be a daemon set will be created out of it. Okay, as simple as that. And the temple under the template we are doing the metadata labels. Okay, again we are defining the cube apps. Then in the annotations, in annotations we are doing the IAM rule. Okay, we are binding the IAM rule of service account like Fluentd. In the specifications, we are specifying the containers. In the containers we are defining the environments. Okay, in the environment you see we are defining the reason, cluster name. Right, in the image, right, that is what I was telling here. So this is the image, right? You see it's a this is the actual image URL. Okay, so this is the public hub image URL in general. Yeah, so that is a Fluentd Kubernetes daemon set version 1 of type daemon. It's a Debian. Okay, it's a OS version of Debian, and the CloudWatch. Okay, this is the image which we. Okay, so earlier I was saying like this is the application name, but this application will be created with using image. Okay, so that is I'm just correcting the statement which I have given just above. Yeah, so here this is the image which will be picked from the Docker hub, and your application called Fluentd to CloudWatch will be created. Yeah, all at the image policies if not present. Yeah, and then the name is this is what we are giving, and we are specifying certain resource limits like memory is this much, CPU is this much, and this is what the request memory can be consumed by this pod or daemon set. And finally, certain configurations are being done here, okay, which is specific to this daemon set. Probably if you would like to manage at the production level, maybe you have to go through this. Yeah. All right. So next one, finally, we are doing the service account mapping, service account. Yeah. And finally, we are telling the volumes. Okay. Something, but how are we configuring the logs volumes? Yeah. And this is the volume configurations are being done. Okay, in general, this is a big file, pretty big file. Probably, you can, go through in detail, once. Anyways, I will be sharing this file into the GitHub repo, and the GitHub repo link will be, added in my video description. Please find it from there. Yeah. All right. So to run this command, what I did is I just did a, just run the kubectl apply -f and config daemonset.yaml file. So this is what I did here, and yeah, so this is the daemon set configurations, and you see our daemon set is being created here. Yeah, and that's all. So then I after that I suddenly I was very curious and run a command called kubectl get daemon set present in the namespace kubectl hyphen, right? That is get ds is nothing but daemon set hyphen n is nothing but namespace belongs to the cube hyphen system. Then you are getting the the daemon sets are been running under the cube system namespace. Yeah. All right. I am checking those the same thing. All right. And after that, I try to I will go to the next steps, and I will explain the implications of the next steps. All right. So right now we have set. Okay, we are set. All right. What when I say set in the sense, one more thing I would like to tell is that I would like to highlight here is when I say set. Okay, when I say set in the sense we have configured the EKS cluster, we configured the Fluentd, and we configure the Fluentd configurations in such a way that it has to push the logs to the CloudWatch log groups. CloudWatch log groups is a kind of a container which will be available already in the AWS EKS cluster, but the logs groups will be dynamically created within the CloudWatch service. Yeah. All right. So now we are set, but but still the logs will not be generated. Why? Because we have not deployed any applications. Okay. So in such cases, what I do is what we have to do is we have to deploy some dummy application. Okay. So for that case, to show you that logs are coming, what I did is I am creating a sample application. Okay. So this is my sample application, and I'm deploying my sample application in this my AKS cluster with using a kubectl apply -f, nothing but again same commands. Okay. This is the file. Here we are creating a namespace called game dot namespace with the name game-2048, and we are deploying the the pods with these specifications. Okay, and once the pod is been deployed, so you see I am deploying the pods here. Yeah, and I'm retrieving the pods. Okay, so if I go down, so kubectl get pods, and this is the pods. Yeah, and again I'm just checking the daemon set. All right, so now pod also been been set. Yeah. So if we can show you the demonstrate status now, so if I'm running the command again, that is get ds, that is a daemon set. Yeah. So we should be seeing our daemon sets being available here. All right, so it is taking some time. Anyways, I will give you, so while it is coming here, so you see it has came before I wind it up. All right, so right now we are done with the setup, but not yet. Okay, so now we are almost done, but one step I would like to tell you is when the EKS cluster is being created, it will have a node group. Okay, so if you go to the EKS cluster, let me go to the EKS cluster. Under the okay, so let me go back again. So this is our EKS cluster, and if I go to the EKS cluster, right, under the nodes, under the compute option, we have the node group. On the node group, a profile, an instance profile will be created. Okay, so this is, or you can call it as a node IAM role. Right, you have to go to this role and add the required permissions. Okay, don't forget this one. This is very, very important, because with this, without these permissions, Fluentd cannot work. Okay, Fluentd cannot push the logs to the CloudWatch log groups. For this demo purpose, I have added the administrator access. Anyways, this is a node IAM role, right? That is okay. So I just given a administrator access, but in production, maybe you have to fine grain it. Yeah. All right. So once this has been set, then here you go. If you go to the CloudWatch log groups, okay. So this is my CloudWatch logs. This is my CloudWatch, and I go to the CloudWatch log groups, right? And as I was explaining under the config. Okay, so if we go to the config, so what is the log group name? So log group name is it is starting with Kubernetes -nest // okay, and with the reason name and our EKS cluster name. Okay, with our EKS cluster name, and yeah. So let me go above bit above. Yeah, so this is the place. Okay, so generally there are multiple logs have been created. Let me see, okay, how many logs groups we are been pushing here. So if I go here, so here you go, right? The logs are being pushed under my EKS. Okay, that is my EKS container. This is the log group, which got created once my setup is successfully completed. Okay, and here you see the logs are being pushed. Okay, so it has been started from this time to this time, and logs are being keep on pushing under this one. Okay, and the logs are being pushed for multiple tasks. You see the Fluentd CloudWatch logs, proxy logs, core DNS logs, yeah. AWS node logs are also being pushed. Okay, so if you go to the Fluentd logs, it will tell like what the Fluentd is doing, yeah. And you see the logs are being pushing, yeah. So logs are being pushed. If we expand this log, so probably it is very big. Here you go, right? So this is what it is telling. And similarly, you see the multiple components of the Kubernetes EKS cluster related logs are being pushed. Okay, kubeproxy is a component within the EKS cluster. Core DNS is a component within the EKS cluster. Okay, all the logs belongs to these very, very important components of EKS clusters are also being pushed. Okay. All right, so that's all for now. I have successfully shown the things to be shown here, like how to create a EKS cluster, how to configure the Fluentd to extract the logs and push it under a CloudWatch log groups by using Kubernetes config map, then deploy the Fluentd as a daemon set, right? And finally, adding the required permissions, add the node groups, right? Node groups IAM role, and then finally it has started to push the logs under the CloudWatch log groups. Okay, it has independently created a CloudWatch log groups with this name. Yeah, this is the name. Yeah, and you see that we are seeing that multiple logs have been pushed for belongs to the multiple components of AWS EKS cluster. Yeah. All right, so that's all for now. Thank you very much for watching my videos. Kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, thank you. Thanks a lot.